Today I'll be talking about different addressing modes. Firstly, we need to understand what are addressing modes. An addressing mode is basically used to find out how exactly we're going to access the operands. According to the way we're going to access the operand, they're classified into immediate, direct, indirect, register, and register indirect addressing mode. Firstly, we look into immediate addressing mode. In immediate addressing mode, the operand is the part of the instruction itself. As you can see in this example, add ax, 5h, where 5h is the operand. It is immediately available as a part of the instruction. Hence, the advantage here would be no memory references. Hence, because there is no memory references, it is faster to access. The next addressing mode is direct addressing mode. In direct addressing mode, what we're going to have is the operand is given as a part of the, as an address is being contained in the address field. Say for example, you have add ax, value. Here value will be resolved into the address. At that address we have the operand we need to work on. So that's your direct addressing mode. The advantages, the way it works here is you have single memory reference to the access the data, and advantages, you need not have to do an additional effective calculations here. So next we have indirect addressing mode. In indirect addressing mode, what we want to do here is, here we have your instruction, here you have A. This A will result to a symbolic address. At that address, we have another address which will actually contain the operand. That is, example, you can see here in this, suppose A is resolved to a location 1000. At location 1000, you have an address which will be pointing to the operand. Next is your register addressing mode. In register addressing mode, the operand you're looking for is directly available in the registers in the instruction itself. So here Bx will contain the operand directly, and hence the advantage here is that it does not need any memory access and it is faster to use since the operand is directly available in the registers by itself. The next addressing mode is register. Okay, this is your register addressing mode where you have no memory access, very fast execution. So we are working with registers, hence the performance will be better. So next you have register indirect addressing mode. In register indirect addressing mode, the register will contain the address of the operand you want to fetch for. Say for example, in this example, we have move ax, bx. Your bx contains the address of the operand. Say for example, it was 1000. At location 1000, you have the operand 50 which is available. So next we have displacement addressing mode. In displacement addressing mode, what we're going to have is we have a base register plus the displacement. So your registers can be any general purpose register. They are not specific to any particular register here. So what happens here is, say A contains a base address, say for example 1000, and R contains a displacement. We add up to this and we obtain an address location of 1050. At location 1050, we have the operand we are looking for. So next is your relative addressing mode. In this relative addressing mode, we are going to specifically use program counter as one of the registers which can contain the base address. So here again it is similar to your displacement addressing mode, but the difference here is we are going to use program counter in place of any general purpose register. So program counter contains your base address plus you have your displacement. So that will give you the actual content of your operand. So this is the end of the sessions. We are looking into different addressing mode here. That is your immediate, you have your direct, indirect, register, register indirect, displacement, and your relative addressing mode. We understood what is actually your addressing mode and the advantages of using different addressing mode. Thank you.